So for my top portfolio, I got geodesic domes. So part one here is just introduction to geodesic domes and what are they. So they were invented by Buckminster Fuller in the late 1940s, and we can see how geodesic domes relate to construction studies with architecture and such, and in science, where you have forces and the tension and loads. Then you can see top right corner, we have where do we see geodesic domes in science communication graphics, and we can see how it came up in 2013 Leaving Cert, and we have some learning intentions. So part two is stimulating pupil interest. So we have a look here at student-led learning, focuses on strengths, showing value in the topic, and helping student organisation. We looked also at Clove's experimental learning cycle and how all four stages must be completed for students to have engaged in effective learning. So part three here is just the key principles. So key principles that students have taken from junior cert cycle. So orthographic projection, basic geometric shapes and constructions, and plane figures. So then continue on with the key principles, we're looking at the Leaving Cert graphic syllabus. So students will be looking at circumscribing faces, edges and vertices, regular polyhedra, spherical geometry, and frequency of geodesic domes, and we can see some examples of them there. So then part four was anticipated student difficulties, so visualization. So a lot of students would find it hard to visualize geodesic domes as a 2D image on flat surface. So the likes of making physical models and 3D renderings on like SolidWorks and AutoCAD is a good idea. So then we have geodesic dome frequencies. It's kind of hard for students to understand, and a way to solve this problem is by having students discuss and explain back to the teacher how dome frequency works. So then some understanding of the key principles. This can be difficult for students. It might be easy to understand the junior cert ones, but the key principles relating to geodesic domes from the Leaving Cert syllabus may be harder. And lastly then, some exam style and level questions. These can be quite difficult for students, and since there's a lack of them out there, it can be hard for students to get practice without the teacher creating their own. So part five, resource development. So you can just see here I made a cardboard model of a geodesic dome which students could pick up and look at. So then assessment topic, here's a question I made for students, and it's just a geodesic dome, and here's the solution. So just the question rationale, students have to have a good level of knowledge on geodesic domes to be able to complete this question, and you can just see on the right hand side there the marking scheme I've made out for it, and it is out of 45 marks in total.